Okay, today's lesson is on the idea of an exponential function. A function is a set of operations that you've applied to a variable. You've been dealing with them already from year 8 to year 9 to year 10. You just didn't call them that. I'll give you an example. If I have this, 2x plus 3, that is a function. You've probably seen something like that before, but you never called it a function. If I have 2x plus 3, what am I doing to x? What is the 2 doing to x? What's the sign between 2 and x that we don't write in maths? Timesing. So that function is actually multiply x by 2. And then after I've done the 2 times by x, what's the other thing that I'm doing to the variable? Adding 3. So hopefully it's not untrue that you have been dealing with functions, you just never called it that. Up to this point, you've dealt with something called linear functions. Why is it linear? Because x is to the power of 1. But what did I hammer you with last week? Were we dealing with to the power of 1, or were we dealing with to power of 15, power of 6? We were dealing with powers all the time. So this stuff that you were doing before, it was linear, because if I graph it on a plane, have you seen this before? Like coordinates? If I graph something that looks like 2x plus 3, it's going to form a straight line. Let me show you. 2x plus 3 is the thing that I want to graph. If I made x equals 0, what's 2 times by 0 going to be? What's anything times by 0? 0. If I added 3 to 0, what am I going to get? 0 plus 3. 3. So what does that mean? What does this maths have to do with this Cartesian plane? X. Which axis is the x-axis? The horizontal one or the vertical one? You tell me. Horizontal, good. So what's the y-axis going to be? The vertical one. So if x is 0, whereabout is x 0 along the horizontal one? Where? In the middle. Okay, I'm starting in the middle. But that's not where the point is yet, because this point, I put a dot at 0, 0. But I want a dot at 0 and y is 3. So whereabouts is that dot going to go if my coordinate is 0, 3? If I start here, would I go up or down? Up how many? 0, 3 is there. So that's my first dot. When x is equal to 0, y is equal to 3. That's just a dot. I don't have a line yet. Let's do the same thing for x is equal to 1. I'm going to put x is equal to 1 into 2x plus 3. What's 2 lots of 1? 2 times 1. 2. Add 3 to it. What's 2 times 1? Add 3. 5. Now I have 2 dots. I have a dot when x is equal to 1, which is here. What is y going to equal? What does it say there? 5? So my second dot is going to be at 1, 5. I've got a second dot there. Let's do x is equal to 2. What's 2 lots of 2? 4. Add 3 to that. What's 4 plus 3? What's this dot going to look like? When x is equal to 2, which is here, what's y going to be? 7, which is going to be up there. Is that forming a straight line? If I drew a line through that, that forms a straight line. That's all you have dealt with up until this point in high school. Year 8, year 9, now year 10 it changes. Okay? Because that's linear. What power is x to there? Is there a power written over that? Do I see a small number to the right of this? So that's to the power of 1. That's all you've done. This is where the copying should start. So here, don't even worry about that grid there. I'm just trying to go back to what you've done previously. If you haven't done that, I need to speak to your previous teachers. This is where you need a copy. What is an exponential function? An exponential function is just a function where the variable is a power. What do you notice about the x here? Is that a power? Is it up to the right? Is it written small? That's an exponential function. Take a seat. I can't say, this is a recording, so don't make any noise, okay? Where is the x here? Is that small and written above? Yes or no? So that's also an exponential function. Where is the x here? Is that a power? That's also exponential. If I wrote this, I don't know, y is equal to 3x plus 2. Is the variable a power? Yes or no? Is it small and up to the right? Or is x just normal size? Oh, am I talking to ghosts here? What? No, it's not a power. So this is not exponential. Not exponential. Why are these exponential? Because x is a power. Get down to here, at least. If it's not clear right now, then you get it when you do your practice exercises. Get down to the start, please. Do you have a maths book? Did you get any paperwork or anything? Do you need something to write with? Can I find my pen back after? Write your name on the front. I'll sit down with you and the other new student. Well, you're not new, you just have been away. Anything in blue is what I think you should get down. Anything in black is just to help me teach you, okay? And this will be recorded and put onto DayMap after the lesson's done. Well, those mags today, I'm showing you how these connect to Bluetooth and self-less. So at this point, literally the only thing you need to understand is it's exponential if the letter x is a power. That's it. If it's not a power, it's linear. Alright, there's nothing actually beyond this. So I'll continue and then you'll have time to get down whatever you need. I'm going to scroll up quickly to remind you. This thing that we graphed is this function. Y is equal to 2x plus 3. Is that x a power or is it just normal size? It's normal size. So it's going to form a straight line if I graph it. If I look at this graph, how much are the dots going up each time? What step is the dot taking? Every time I go across one, how far up has it gone? How many? It's gone up 2. That's not going to change. It's always going to go up 2. I could draw this forever. And every time I step once to the right, like this, I'm going to step up twice. That's for when it's linear. We're going to draw this one now. What do you notice about x? Is it normal size or is it a power? It's a power now. And all of this writing here is to tell you that if x is a power, we're talking about an exponential function. That's it. It's not going to form a straight line. So if I made x equal 0, and I plug that into my function, 2 to the power of x, I'm going to replace x with 0. What is anything to the power of 0? 1. So my first dot on the grid is going to be at x is equal to 0, y is equal to 1. So my first dot goes there. That might not look any different to the previous graph. I can't see if it's a straight line or if it's curved because I don't have another dot here. Let's try this. If I've made x equal 1, 2 to the power of x, what did I just say x is? It's 1 now. What's 2 to the power of 1? What's anything to the power of 1? Itself. So when x is equal to 1, along the x-axis, I'm at 1 here. What is my y going to be? 2. So I jump up twice. Mr. T, what substances are you on? This is still a straight line. Because it's going up diagonally. Yeah? But I haven't drawn 3 dots yet. So let's draw 3. If x is equal to 2, the function is going to be 2 to the power of 2. See how this relates to your previous week? What does that power mean? How many times am I going to times 2 by itself? Twice. 2 times 2 is what? So where's my last dot going to be? When x is equal to 2, y is going to be 4. Is that straight anymore? It went up diagonally here. But what happened now? You stepped up 2. It curves up twice. That's the worst little curved line over there. That's an exponential function. Why is this useful to us? Why do we need to learn about this in year 10? Does anyone here have a savings account at the bank? Yes or no? Do you know how many percent it pays you?
7%.
7% is pretty damn good. What does that mean? If you had $100 in the bank, after 1 year, they're literally just going to give you 7% of that. 7% of 100, $7 for free. That's called interest. I'm going to teach you about money maths later. We need to hammer the algebra now to get you in the mode of it. The bank doesn't just, in the cartoons that you probably watch, you probably think that the bank just gets your money and puts it in giant piles. Is that what you think? No, they use it. They use it. They buy properties and stuff. They try to grow your money. All your bank account is saying is we owe you back this whenever you want. If you've got $5,000 in your bank account, all that means is that you can withdraw $5,000 from them anytime. Okay? But if you've got a savings account that pays interest, they pay you for having money in there. So, okay, if you had $100 in your savings account, is $7 in a year much? No. What if you had 10 grand in there? Is 7% going to be pretty good? And then after that 1 year, you've earned like $7,000 of interest. If you keep that 7 grand in there, are you going to get 7% of that 7 grand as well? It's going to grow like this. If you have an interest earning account that doesn't pay you interest, your money's going to grow a straight line. Which is better, the straight line or the one that's rocketing upwards? What would you want to do? The one that curves up because it grows faster. Okay? So what we do is teach you, this algebra doesn't mean anything right now, but it's leading to something. You need to trust me that it leads to something. Look at me. Okay? It leads to something, but you need to handle the basics to start off with. Okay? So what I'm going to do, I'm going to stop the video there.